Hi guys, so welcome to episode 5 of the final year project diaries, right? In the previous episode, we were able to start something on the creation of nodes and then keeping track of nodes whenever the user connects components, right? And then we ended up having this problem where we said, how do we solve this short circuit problem? Like, how are you able to get the short circuit between two different nodes? That's what I'm here to solve today. Now, I realized that the short circuit would only occur if the new connection, the wire that is being connected, is actually between two nodes. How do I say this? The short circuit would only occur if the short circuit will only occur if the new connection that you are making is actually between two existing nodes already. So the code that we are writing here, we have to make some changes to it, I guess, because for this particular case, I go through and then I find out the nodes that it has, intersected with. That's what I have been trying to do, right? So instead of doing this thing that I'm doing over here, I could rather make the intersections, because if it actually intersects with two nodes, you can only intersect with a maximum of two nodes, because I am pretty sure that whatever connection I'm making, whatever is coming in from this selected terminals will always be two items, two terminal locations. So if the intersection is actually with two different nodes, then it means that the two nodes belong to two different nodes. So it means that there is a short circuit. If it's only one, then it means that it's a new component that you're adding to an existing node. If it's zero, then it means it's a new node that you're creating all along. So what I'm trying to do is that instead of having intersection in there, I want to have intersection outside, or should I say intersections outside, and then set this to a set, right? And then after my for loop, whenever I get the intersection like this, what I'm going to do is that this is the, should I say, internal intersection. Then I could write something like intersections dot union or should I rather do union update? Okay, I'm not sure there's union update. There's only union. So intersections should be equal to intersections.union intersection. So, if there is an empty set and I get this, if it's an empty set and I get this, I would end up, let's see, hold on. Let me think this through well. So I have intersections here as a set, right? Initially it would be empty. Now for each of the nodes, it's going to try and find out if that node has something in common with the terminals that are selected to be connected. If it does, it means that this new intersection, the singular one, would have at least one element in there, and that one element would finding the union of that one element and these intersections over here would sort of be adding that one element to these intersections over here. So at the end of the for loop, what I'm going to do is this. I'm going to be checking the size of the intersection. I am very sure that the intersection could only ever be two elements, because there are only two elements in the new terminal list. So if I'm going to intersect with something, maximum two elements, right? So if the length of it is equal to if the length of it is equal to 1, which means that if the length of it is equal to 1, it means that there is like it's only one of the components, it's only one of the nodes that intersects with the new connection I'm making, which means that I am basically going to like append to that particular node, right? I hope you get like what I'm trying to say over here. But the thing is that if this new connection, let me remove this break from here because it's no more needed. Elif, length of intersection, not intersection, intersections. Yeah, the one at the top here. Elif, the length of the intersections is equal to 2. Then it means that there is a short circuit. And I'm supposed to handle that. And the last one will be elif length of intersections is equal to 0, which is actually the else block anyway. So it means that what there is a new connection that doesn't belong to an existing node, and I'm supposed to basically like create a new node for it. So this makes sense. So how I'm going to handle the short circuit here is what I should be thinking about. So I'm also thinking of basically creating a short circuit as part of the middleware here. So as like a type. And so if I come here, I could have something like, short, let me remove this. I could have something like short circuit. And this would also be a class. Yes, of course, it will have its own unique ID, as usual. Then there would be, like, instead of it having components terminals, it would rather have the nodes that it's actually, the nodes that are actually getting short circuited. So nodes involved in the short circuit, it should be 2, right? So like I'm guessing it should be like just one tuple of the nodes that are actually being short circuited. I hope like there is some sort of understanding here. That reminds me, if I need the nodes, then I need to be keeping track of the nodes and not. Okay, let's calm down. I need to go back here and look at something. Wait, I'm looking for campus. First of all, if the intersection is equal to 1, I'm just going to use that. Even here, I should be using like a for loop or something. For terminal in so I'm keeping track of the nodes that it has there is an intersection with. So nodes intersected with. Initially, I'm going to start that with 0, and whenever there is an intersection, So like I'm checking the intersections over here, right? Whenever there's an intersection, I basically update it. No, actually, it should be the actual nodes, right? So maybe a list of nodes. So if length of I mean, is it possible that this intersection over here would ever be? Is it possible that this intersection here would ever be anything more than like 1? Because if I'm considering one node and I'm connecting something to that node, yeah, I mean, it's possible that it would be. Wait, I need to rethink this. It's possible that it would be more than 1, alright. Like, imagine a situation where I think I need to run the application again, but I can't run it without actually, doing something. You know what? I'm running it. Like, I want to create a situation where I think it's possible that the same node would have more than one intersection. And why isn't the wire 2 working? So in a situation like this, all of these belong to the same node, right? If I connect this and this together, will you guys consider this a short circuit? Like, is this considered a short circuit, or it's all part of the same node? I mean, like, this is where everything gets weird, right? Because I'm thinking too much, like, of a lot of situations right now. Initially, I thought that, oh, okay, if I want a short circuit, then as long as it's a line between two different two different nodes, then that's a short circuit. But it's possible that my line would actually be like connecting the same node. Let's Google something. Is a connection to the same can a short circuit occur between the same node? So they are saying that a resistor is short-circuited if both of its ends are connected to the same node. For instance, if I were to like connect this to this, then that would be a short circuit, right? But if you look at this, the two ends of these resistors are not connected to the same node. But then, like this connection that I've done over here, the 2 points actually belong to a single node already. So is it a short circuit? That's the question I should be asking. Is that a short circuit? I think I'm going to ask ChatGPT because I'm so confused right now. chat.openai.com/chat. Right, so can I... Okay, no, let me just describe this. Is this situation a short circuit? I have 4 resistors. Connected with all their top, I have 4 resistors. Let's assume that the resistors have a top terminal and a bottom terminal. The top terminals are all connected to the same node through adjacent connections, right? If I now connect resistor 1 to resistor 3, if I now connect the top part of resistor 1 to the top terminal of resistor 3, is this a short circuit? If not, explain. It says that no, connecting the top terminal of the resistor 1 to the top terminal of resistor 3 does not necessarily create a short circuit. A short circuit occurs when there is a low resistance path between the power supply terminals, bypassing most of the circuit components. In your case, if the bottom terminals of all 4 resistors are not connected together or to any other element in the circuit, then connecting the top terminal of the resistor 1 to the top terminal of resistor 3 does not create a short circuit. It simply forms a direct connection between these 2 resistors, bypassing resistor 2. However, the circuit will still have the remaining resistor 4 unaffected and could continue to function with modified connection. A short circuit would occur if the top and bottom terminals of resistor 1 or resistor 3 were directly connected without any other elements in between. Okay, so it's saying that as I've done this, if this was connected like this, if the bottom part of this was connected somehow, here is a problem with my software. I mean, there's no path tracing algorithm, so it's all just messed up like this. But it's saying that if this and this were connected like this, then there would be a short circuit. I still don't really understand what that means, right? Short circuit would occur if the top bottom terminals of a resistor 1 or resistor 3 were directly connected without any other terminals in between. This would create a low resistance. Yeah, I understand this. Yes. So it's not a short circuit then. So as long as I make sure that the bottom part, the bottom terminals of these resistors don't end up getting connected to the node formed by the connections of the top terminals, there is no short circuit. What effect does the direct connection of the top terminals of 3 and 4, sorry, not 3 and 4, 1 and 3, right? Then cause. Oh, so it will just be seen as a parallel connection rather, instead of thinking of it as a short circuit. Damn. Paul, I think I have problems, right? I have problems, right? Tell me. Okay, so yeah, it is possible that it would be 2, right? And I think this logic here should actually change. Like, I was thinking that the intersections would only be 1, but it's possible that the intersections would actually be 2. You know what I'm saying? I know for a fact that I'm connecting 2 things. So if I think I need to like make a sort of deductions based on whether, like, I'll know whether it's a short circuit or not, or whether it's a parallel connection or not, depending on the values in here. For instance, if the node that it has intersected with is just 1, but the intersections are more, then it means that it's actually a parallel connection, because, like, I hope you get what I'm trying to say. So it's possible that this will be more than 1. Where is it? It's possible that this intersection, sorry, I highlighted the wrong thing. It's possible that this intersection will be more than 1. Possible that it would contain more than 1 will occur. This will occur in parallel connections, right? So if I'm able to get that like those intersections, right? And I add, like I'm basically going to do the union thing again, right? So, but then I should be sure, like if the length of the intersections is greater than 0, or it's not equal to 0, then it means it has definitely intersected with that node. So I'm going to do nodes intersected with dot append. Then I'll do I'm just going to do node ID. I mean, why do I need to like keep track of the actual nodes if I could just keep track of the ID, right? So if there is at least one intersection with the node, I keep track of the node. And then here, keep track of all the intersections, right? So back here, if the length of the intersection is equal to 1, definitely the node 2 would be equal to 1, like the length of the node, the length of the nodes intersected with would also be equal to 1. I think that makes sense, because obviously if you intersected with you have only one intersection as like should I say the terminal intersection, then there will definitely be only one node. Like this one is straightforward, right? See, but then if the length of the intersection is equal to 2 and the length of, or not necessarily equal to 2, right? Let's say greater than 2. But the length of the intersections would always be equal to, like, it can't go beyond 2. Reason being that, like, there are only two things that you are connecting at a point in time, so you can't go beyond that. That makes sense. So if the length of the intersection is equal to 2, or should I say is greater than or equal to 2, let's just use 2, like we are sure that it's 2. If the length of the intersection is greater than 2 and the length of the nodes intersected with, it's greater than 1, or it's greater than or equal to 2. If it's greater than or equal to 2, then it means that it's not a short circuit. Oh no, it means that it's a short circuit. It's like there are intersections with nodes, alright, but then there are intersections with nodes, alright, but there are intersections, alright, but then it's actually between two different nodes. So it's actually should I say a short circuit between those two nodes. I hope you get what I'm trying to say. So I think this should also be, it can't be more than 2, right? How can you possibly intersect with more than 2? Like if this is 1, this definitely has to be 1, right? If this is 1, this has to be 1, and this can never be greater than this. This can never be greater than this. If this is 1, this has to be 1, and this can never be greater than this. right? If this is 2, this can either be 2, or it can be 1. But if it is 2, 2, then it means that there is a short circuit, because the new connection intersects with more than one node, right? And yeah, so like try and figure out how we are going to do it. Now it's also possible that the length of the intersections would be equal to 2, alright, and the length of the nodes intersected with would be equal to 1. In this case, and put a pass here first. In this case, it means that there is a parallel connection somewhere. So what we'll just do is to basically try and append Now we actually don't know what we should do when there is a parallel connection. I mean, if there is a short circuit, we want to like create a short circuit instance. Like if there is a parallel connection, how do you keep track of the parallel connection, right? That's the question. If this is equal to 0, definitely this has to be equal to 0. I mean, it doesn't make sense that the intersections would be 0. So if this got 0, definitely the length of the nodes intersected with should also be equal to 0. It can't be any like higher than that, because if you are telling me that you've intersected with nodes, then how come this is 0? It doesn't make sense, right? Unless the logic I wrote up here is not right. Right? This 0, this has to be 0. So I need to rewrite this one. It looks so weird in my eyes. If this is 1, this has to be at least 1. If this is 2, this can be 2 or this can be 1. Then this is where the tricky aspect is all right. I mean, just look at what's happening here. If there is a short circuit, I mean, we can deal with that by creating a short circuit instance. If there is a parallel connection, I don't know how to do that. Like, I don't know what to do here. What should we? That's the question. I think it's like I figured out how to know whether there is a parallel connection or not. But I think I should look at how pyqt works, because that's not going to be easy for the simulation. pyqt parallel. Is that even how to spell parallel? It looks weird in my eye, but it seems to be correct. pyqt parallel resistor. And it has 2 resistors. What did ChatGPT actually say about those resistors in parallel? It says that it creates a parallel connection between those 2 resistors. Okay. So the 2 resistors that are So it means that here there would be like a parallel connection between the two components whose terminals are involved. Wow, this is so messed up, right? Like, look at the code I'm writing here, it's so messed up. In any case, guys, I think this video is getting very long, and so we'll continue to deal with this one another time. Like, I've still not figured out this. I might do some research on my own. I mean, I shouldn't always do all the research on camera, or else I'll just be like wasting your time. But I'm hoping that you guys are following what we are doing, and you are understanding like the logic that's going on here. If there is any problem or anything that you don't understand, please let me know. And again, sorry for a boring video. Cheers.